Okay, let's take a look at this. Now, part of the issue here is to figure out what u and dv should be. Typically, you want to be the part that when you take the derivative of it will cause it to disappear eventually. So here I'm going to say is u, and this part I'll say is dv. If I take the derivative of e to the 2x, it's e to the 2x times the derivative of 2x. So that will not disappear if I take the derivative of it. That's why I said this was u. Now for our formula, we need du. The derivative of x is 1, and then I have to put on a dx. I also need v. And v you get by taking the integral of e to the 2x dx. Now this would be a substitution, and I'll use w. So w would be 2x dw. Derivative of 2x is 2, then we have to add on a dx. So this can be rewritten as the integral of e to the, actually, I put my 2 in there, don't I? Okay, so I'll offset it with 1/2 out in front, and then I'll put a 2 inside. So I'm going to have 1/2 integral. Now 2 dx, that gets replaced with dw. 2x gets replaced. So this becomes e to the w dw. So the integral of e to the w is e to the w. We don't put the plus c on here at this point. And then we're going to put our w back in. We said w is equal to 2x. So now we're ready to plug into our formula. So we're going to have uv minus the integral of v du. So this becomes u, which is x, times v, which is 1/2 e to the 2x, minus the integral of v, which is 1/2 e to the 2x du, and du was dx. So that's going to give us 1/2 x e to the 2x. I can take the 1/2 and put it out in front. The integral of e to the 2x dx. Now we just found the integral of e to the 2x dx right here, which is equal to this right here. So this becomes 1/2 x e to the 2x minus 1/2 times this right here, which is 1/2 e to the 2x. And then now I'll put a plus c on. So that gives us 1/2 x e to the 2x minus 1/4 e to the 2x plus c. Okay. Number 9. Integral of x e to the 2x dx. One way that that people do on this is they got 3 columns as a shortcut, STI. And d is our derivative, I is our integral. So we put x here, and the derivative of x is 1, and then derivative of 1 is 0. Your idea is when you take the derivative, you want to get it down to 0. And so we plus, minus, plus. And over here, this would be e to the 2x dx. So that'd be our integral. And the integral of e to the 2x dx from above is equal to 1/2 e to the 2x. Now I'm not going to put the integral and dx there. It's implied on these. So for this next one, the 1/2 carries down out in front. And we've already said the integral of e to the x, e to the 2x dx is going to be equal to 1/2 e to the 2x. So again, these aren't actually part of this. I was just doing that to emphasize we're finding the integral. Now, you go cross like this, down like this. Cross like this, down like this. Now I don't need to do the plus 0 because that just drops away. But here we got a plus x 1/2 x 1/2 e to the 2x, which you see is going to give us our first part of the answer here. Minus 1 times 1/2 times 1/2 is 1/4 e to the 2x, and then we add on our plus c, which then gives us this answer right here. Some people like this table because it's a very quick way to find the answer. Now let me see if I can find one with an x squared. Well, maybe. Integration by parts. Okay. Now here's one, but that's not what I was looking for. I guess I could use it. I just don't see a real good example. Natural log is kind of a different one, but I guess I might as well show it. Okay, number 11. The integral of x to the 5th natural log of x dx. Now here that table really doesn't work out very well. But if I said this was u, and this was dv, then it wouldn't go anywhere. Because it would have the integral of natural log of x dx. But if I said this was u, and then this right here was my dv, well, let's see how that works out. Okay, so u is equal to natural log of x. The derivative of that would be 1 over x. As I put dx, but that's for the integral. Okay, the derivative of natural log of x is 1 over x. Okay, now dv would equal to this right here. So let me put that down. X to the 5th dx. So v is going to equal to the integral of x to the 5th dx. You add 1 to your power divided by a new power. So 1/6 x to the 6. We put a plus c on, but we don't need to put that. And let's see, what do we got? uv minus the integral of, what is the formula? Integral of v du. Okay, uv. U was natural log of x times v. What was v? 1/6 x to the 6 minus the integral of v, which is 1/6 x to the 6 du, which is 1 over x, and oh, I forgot to put dx in here, dx there. So then we got 1/6 x to the 6 natural log of x minus, I can take the 1/6 and put it out in front. Now the nice part about this is x to the 6 over x gives us x to the 5th. And then it just becomes a normal integration. So we got 1/6 x to the 6 natural log of x minus 1/6, add 1 new power divided by new power, and that gives us 1/6 x to the 6, and I'll put a plus c. So that gives us 1/6 x to the 6 natural log of x minus 1 over 36 x to the 6 plus c. I wrote my formula down wrong. No, that's right. Now, I don't think there's any way to do the SDI table based upon this I can see of, but that would be our answer.